Thanks for all of you coming here to this session. It's pretty exciting, actually, because I've been in the ICS security field now since, oh gosh, it's 15 years. And these meetings were a lot smaller 15 years ago. Like, we could probably have fit into about that little corner over there. And to see a lot of new faces and people that I don't know is actually really great. So my background, of course, was out of the British Columbia Institute of Technology, running the research center down there, and then eventually working and putting together the team that eventually became the World Tech Achilles team, and then also putting together the Tofino team and running Tofino. And one of the cool things about doing all these projects, and one of the frustrating things about doing these projects that come out of basic research, is that after you're into them for 3 or 4 years, you see other opportunities. You see spots where your silver bullet is not covering it. And I certainly would see a lot of things while we were at Tofino. I'd go, wow, that's a problem. That's a real problem. And we're not going to do anything about it because I've got to work on a firewall. So one of the things that really scared me while I was at Tofino, and things like Stuxnet really drove it home. There, I've mentioned Stuxnet, that's it. Was how do you know that the bits you're loading into that controller are the bits that the controller manufacturer intended you to load in? You know, when you're doing a firmware upgrade, how do you know those are that's the right firmware, and not firmware that's been, say, modified by a nation state like North Korea? You know, how do you know the difference? It's probably you don't. I was always concerned, and in fact, I've seen a number of cases in my family where enthusiasm for patching has resulted in some real disasters. My mother-in-law called me a little while ago, I guess it's about a year ago now, telling me that her computer wasn't working so good, and she'd just loaded a new Java upgrade onto her computer. Well, that Java upgrade had never seen the insides of Oracle, I can assure you. You know, so she was doing what Keith mentioned, and which everybody says, you know, patch early and patch often. But unfortunately, she wasn't patching with the right stuff. And so I became very, very interested, but I didn't do much about it. How do you detect counterfeit ICS and IoT software? And let's see, let's get the right button here. Middle button? Nope, wrong button.
Far right. Yeah, the right button.
Right button.
But it only works 10% of the time.
Oh, it only works. Okay, good. Well, that's. So I want to talk a little bit about the threat of counterfeit software. I want to talk about some possible solutions. Marty said there's solutions out there for everything, and I'm not so sure. I think we've still got a little ways to go, but we'll have that debate over a beer later or a coffee later. And what are their limitations, and then the research that I'm working on. And right now, this is all about a research project that I'm running for the Department of Homeland Security. So the one that really got me nervous was Dragonfly, and it really exploited the chain of trust between the supplier and users. What happened, if you followed the Dragonfly attacks, was a team of hackers infiltrated at least 3 vendor websites and replaced the valid downloads and upgrade software on those vendor websites with Trojanized versions. So that then, when the well-meaning engineers decided to download the latest version, they were downloading the latest version of Trojanized software. Now, this is where things really go nasty, because once you've broken that trust, now these engineers believe they've got the right software and they're doing the right thing to do the patch. So they will patch that software. They will take that software, carry it past any whitelisting, any firewall, and they will make sure it gets installed in their factory. And if the whitelisting says, no, don't install it, they will override that because they are improving their security. Unfortunately, they're improving their security with counterfeit software. And of course, in the case of Dragonfly, as soon as that software was installed, it would call back home and give the attackers full control of computers sitting and hardware sitting deep inside a plant, inside the firewalls, inside, right down on the plant floor. And this was software that would scan for all the protocols and use the protocols that we love and know, like Modbus and SIP, and OPC. So this is really ICS attacks. So you can see by breaking that chain of trust, what happens is that a lot of the things that we take for granted as proper practices actually start to be used against us, such as whitelisting, such as frequent patching. That's bad, because I think whitelisting and patching are really great tools. I don't want to be, well, I don't actually trust it. That's bad when people start to fail to trust the proper procedures. Sometimes they don't have to be as sophisticated as the Dragonfly attack. Last year, or a year and a bit ago, Rockwell started announcing that somebody was shipping a update called Allen Bradley update.zip. Now, it had nothing to do with Allen Bradley, and if you knew anything about Allen Bradley upgrades, you could tell this was a rat from a mile away. It was actually ransomware. But the mere fact that it was being shipped as Allen Bradley update would have induced potential victims to open it up, install it, unzip it, getting themselves infected. So I call this the software last mile problem. We have very good controls in our software processes in most companies. At Tofino we did, at all the major vendors do. They have really good ways of validating, controlling the quality of the software, all the way up until the moment that the software is made public on a CD, on the website, however it's distributed. At that point, it's, as Keith had said earlier, it's Wild West. You really don't know how that software is going to be distributed and if that software is being tampered with in that distribution model. There's just, basically there's no standard solution to validate the legitimacy of the firmware software you're about to install. Now, if you go to something like an iPhone, they actually have a whole environment. There is a standardized solution in the iPhone environment. But in our world, in the industrial world, and in fact anything to do with embedded product, there is no standardized way of validating that. Now, there are some solutions, and everybody says, well, what about the MD5 hash? Why don't you check that MD5 published hash? Well, there's a few problems. Has anybody actually checked an MD5 hash in the last little while? Put your hands up. Hey, good, we got one. Go. The fact is that it makes things more complicated when you got to go and check a hash before you load software. The second problem, in the case of Dragonfly, if the hashes had been published up on the website, the hackers would have just changed the hash as well as the software. So you have a common mode failure there. Your hashes are typically exposed with the software. And what do you do if a hash fails? Is it been tampered with? Did you just have a bad copy? Is there just a few bits? Did somebody make a mistake? It's a very binary solution to a very grayscale problem. So hashes are really useful, but I honestly don't see them being heavily used in our industry. There's also techniques like code signing, like Microsoft Authenticode, which is a really cool system if you're running on a Windows platform and you're running on Windows 10 platform. But I can assure you, if you're running on Windows NT or XP or even 2003, code signing is not going to work all that good for you. And code signing has a series of challenges, like if you don't have an internet connection in order to do revocations, if your clock is wrong, that can really be entertaining. And mostly, none of our devices actually support code signing. Again, yes, it's great for the Windows boxes, but it's rotten when you come down to the thing that actually matters, the controller. So a year and a bit ago, 2 Januaries ago, we received a grant from the Department of Homeland Security to develop a robust vendor-agnostic solution for validating firmware updates into IoT devices. Not just industrial, it was everything. In fact, mostly the airline industry is what's really driving this. But I think it applies to us as well. We started in January 2017. We've got 5 part-time and full-time researchers working on this. And the idea is, what is a mechanism that will allow us to validate that the firmware we're loading is valid firmware? So we've been looking at different models that we can inject into the existing distribution processes. We want to make it platform agnostic, vendor agnostic. We don't care what the OS underneath it is running. Very important, we want to require no architectural changes. It's a lot of work when you start to massively change the architecture of a control system or even the architecture of your processes. So we want to have something that'll get injected in easily. Otherwise, people won't use it. I mean, there's lots of security out there that is really good and has never seen the light of day because it's too much work. So making it easy to use is really the bottom line. Will this be easier to use than not use? And that's absolutely critical. The model is pretty simple. We work with specific vendors to get fingerprints and metadata from them inside their build and development process on what their firmware looks like. We put that up into a server, trust repository server, and then we have the same fingerprinting tools that we give out to the end users that they can either have embedded in a web client or as a freestanding site tool, and they can run those just prior to doing any installations or on any of their software repository servers, and then they get a verdict, a score back. And eventually we want to start working with third-party tools. We really see this as something that should be integrated into security management systems. So the challenges and where we've really ended up spending a lot of time is how do you ensure low impact on existing users? As I said, if you make something tricky to use, it just doesn't get used. Security is always sort of the last thing that people care about. Getting production out is what matters. As well, we don't live in a perfectly connected world. So we're particularly interested in what do you do about unconnected remote sites. We also live in very bandwidth limited systems, particularly anybody in the oil and gas upstream world. You're very bandwidth limited. You're not going to be trying to upload files over that radio link. So how do you minimize your file transfers? And anybody who's actually looked at file installers know that they're actually a zipped mess of things. So how do you deal with that pile of individual packages that are embedded inside an installer? And then probably the most important thing is how do you handle the duplicates and the near misses? Because you don't want people to panic when they see an error thinking that they're being hacked by some nation state, when in fact all it is that they got a bad download. So we've created a reputation scoring scheme so far. We've put together about 1 million test artifacts from different vendors. We've created what we call the low impact deployment model, and we've got a portal up now that for submission and reporting that we're prototyping. It looks something like that, although that's changed. We made a bunch of changes the other day. So why am I talking? We need some partners. As this part of this DHS project, we need some asset owners to help validate whether they think this model actually would be something that their engineering teams would easily accept. Would it be something that people would like to use? Or is it going to be something that people say, oh no, we're not going to touch this, it's too much work? And also with the vendors to make sure that we can integrate this into their development systems in a way that they don't feel they're losing intellectual property or they're delaying their releases. I think the model has some real potential, and I'll close with that. I think the strengths is if we can make this vendor neutral, operating system neutral, platform neutral, then it really has this chance to be rolled out across our entire industry and have a one-stop solution, whether it's a safety system, a smart valve, a controller, an HMI, some way you can validate it in one stop and not in 10 different ways. I believe we can do this without reinventing cryptography. I think we can use standard, well-proven crypto solutions. And I believe that we're starting to get close to have a model, and this is where I need your guys' help to see if I'm right or am I wrong, something that'll fit into asset owner processes. And lastly, I think this will allow people to keep their intellectual property and their files themselves and not require people to be submitting the files themselves or the vendors, but really the fingerprints and that validation is what you really want to be able to share. So thank you very much, and I guess it's time for questions soon.